Let's see how you did on this one. So I'm going to start with x. You might not have started with x. You might have started with p or t, but I'm going to start with x because I am going to use my exterior angle theorem to figure out what x is. So what that theorem says is these remote interior angles are going to add to the exterior angle. So notice here in this picture, my exterior angle has a measure of 130 degrees. So 130 is equal to 3x minus 6 plus 8x plus 4. Okay, now I use parentheses just so that you can see that we're talking about different angles here, but they really weren't necessary. I can combine like terms. 3x and 8x is 11x. Negative 6 and 4 is negative 2. So 11x minus 2 is equal to 130. Add the 2 to the 130, so 132 is equal to 11x. So 132 divided by 11 leaves me with 12. So x has a value of 12. Okay, so now I want to move on to y. Well, in this picture, I know that I have a linear pair. So I'm going to say that 130 plus 2y equals 180 because, again, I have a linear pair. So that means that 2y, if I subtract the 130 from the 180, that means that 2y is equal to 50. So this angle measure here is 50 degrees. So what does that leave me with y? Y has a value of 25. Well, I know that P is going to be 70 degrees because I have vertical angles. So now I'm going to use the triangle sum theorem, which says that 70, we already said that this angle measure is 50 degrees. So 70 plus 50 plus t equals 180. So 70 and 50 is 120. 120 plus what is 180? 60. So t has a value of 60 degrees. So I know what t is, I know what y is, I know that p is 70, and I know what x is. So what do I have left? I have z and I have r. So z, again, triangle sum theorem, so 70 plus 35 is 105. So 105 plus what is 180? So z is 75 degrees. And so what does that leave me with r? So I can use my linear pair. So 180 minus 75 is going to leave me with 105. And so r has a value of 105. Okay, so I think we have found all of our variables in this one picture. Hopefully you got those right.